Welcome to my presentation today. I brought a few very big topics with me today. Transformative effects of real-time AI, multimodal SQL databases, and large language models. So I'm Christian, I'm leading the product team here at CrateTB, and within the next 20 minutes, I want to take you on this exciting journey and want to give you a visionary approach how we can combine all these different aspects with the help of modern technology and to reduce the zoo of technologies that we have out there. Let's get started with an overview of today's data challenges. Right? As soon as we want to develop a new application, and with application, I mean anything like an end user application, mobile app, a dashboard, a recommendation algorithm, anything that we have in mind, right? And what we need for all these applications is, of course, data. So what usually happens, we start with a new relational database system that gets implemented. We integrate a few data sources, we write our application on top of it. Perfectly fine. Usually we are done in a good amount of time. We need the people that we have already in the company. They can cope with all these requirements. And we can deliver a first iteration of our application, hopefully relatively fast. But what happens next is usually the requirements keep increasing, right? Once you have the application in place, users might come around and say, hey, I need search functionalities. I need a full text search in my application. So what happens? You add a search engine to your technology stack. You introduce a new language on top of that. I used generic words here on this slide, right? Like the search query language. And obviously, you also need to take care of the data integration processes between your relational database in this example and the search engine. And now that you introduce multiple technologies, you also have to work on the application backend side. This can either be additional code that you need. This can also be additional solutions that you introduce, like data virtualization, data federation. And also on the deployment, monitoring, and operations side, you need to invest additional efforts, right? All of a sudden, it's not your relational database system where you might just create a new schema in an existing database, but you start to introduce new technologies to your stack. So as a consequence, obviously, you need more people in your team. You need more skills in your team. And the time increases that you can build up new solutions. And the cost of changes keep increasing here. And maybe you use open source technologies. Your people are able to cope with that. So money is not the biggest problem that we have. And what happens next? You add more sources. You might want to work with your sensor data. So you add a time series database. Again, new technology, new languages that you introduce. Or you work with complex asset descriptions, more complex objects that you want to handle. So you're introducing a document database. And again, a new technology you're introducing and a new language you're introducing. It has an effect on your people, right? You need to learn these technologies. You need to operate these technologies. And as you can see with these arrows that are popping up on this slide as well, you need to take care of data integration and data synchronization processes, right? So definitely the time until you are out with new features and can deliver this to your users increases significantly here. And also the amount of money that you need to spend increases, right? It can be licenses, it can be additional people, can be additional hardware resources that you also need. And last but not least, I mean, we can continue this on and on. You might need geospatial data. And now that we start to talk about artificial intelligence and machine learning, you might need abstract representations of your data, right, in form of vectors, where you need normalized, harmonized representation of multimodal data, of your images, of your texts, right? And this can be represented as vectors. Or when we move into the area of generative AI, of large language models, you want to start to work with embeddings. So you need a vector store, right? And this introduces not just the technology, but also a new language, a new API that you need to put into place. And again, you need to come up with your embeddings. You need to do this data synchronization, right? And you need to keep your data, your metadata, and in this case, our vectors in sync to each other. So again, it raises the amount of people that you need, right? You definitely spend more money on this one and time as well.
So obviously, summarize these issues. If we introduce for every single use case a new data store, right, we have a lot of data synchronization processes that we need to take care of. Second, it's very difficult to manage all these different technologies. Imagine your workload doubles. You need to scale up or scale out this whole infrastructure, right? All of a sudden, you need to scale 6, at least multiple different technologies. And your application backend gets more and more complex. And this application backend can be pure code, speaking multiple languages. It can be something like a data virtualization layer that you introduce. So again, more and more complexity that you need to add. And what is the real risk here? You build up a lot of technical debt. And we all know building technical debt in the form of databases is one of the hardest forms. Code is still technical debt, but it's easier to refactor than really get rid of your data, to move into a lot of migration processes, right? One of the hardest technical debts to get rid of. And I already talked about these implications in terms of people, right? You need multiple skill sets, obviously need more people, and it's usually also very difficult in the market to find people with these highly specialized skills. Time, obviously slow time to value, and changes take very long to be implemented here. And I already mentioned high TCO, high cost of change. And all of this looks now like a lot of spaghetti, and also in real projects, this is usually hidden behind a very nice and well-organized architecture slide, right? But in practice, it's still something like this spaghetti architecture here. So how can we solve it? And how can a technology like CreateDB help you in solving these issues? First of all, it has to be a technology that is able to cope with a lot of different data structures, right? You need to put some relational tables in there. You obviously need to work with time series data when we talk about IoT, when we talk about machine-generated data. Then you want to enrich this time series data, for example, with geospatial information, maybe with some rich documents, some JSON, some information about your assets. You might want to put full text data in there, need to search for full text. We integrated also vector capabilities, right? That you can work with the semantics of your data and can use it. And obviously also needs to be able to store binary objects, storing large files, images, for example. And all of this, that's the beauty, is available or should be available via native SQL. One language, everyone is used to talk this language and to speak to data via SQL. And that's the beauty that a technology like CreateDB can offer you. And as soon as we talk SQL, a lot of people think about very rigid and strict schemas, right? This technology is also able to offer you a dynamic schema. That means at runtime, if some data has been changed in your sources or you have new sensors you want to integrate, just pump it to the database. It won't break. It will adapt dynamically to your new requirements, right? Helps to ease a lot and speed up the development process a lot. And then it comes to the deployment. How should it actually be executed? And who is in the room and who's had to scale relational database systems horizontally? This is something that should be there out of the box, but usually you need additional technologies, right? To keep the data in sync, to set everything up, synchronize your data back and forth between different data centers. And what a technology like CreateDB can offer you is we have a highly distributed execution engine, right? It's a shared nothing architecture. All nodes run the same. You can use commodity hardware, nothing special that you need for it. And when we talk about the ingests and the reads, usually in sensor-based machine-generated data or in AI in general, we have a high concurrency of this data in order to come up with real-time applications. And one customer here, BitMoving, which is the backbone of the largest TV station, some of the largest TV stations on this planet, they track everything. When you click the play button, this ends up in about 100 records inside of the database, right? So they literally hammer the database with multiple millions of inserts per second while having hundreds of thousands of dashboard users live on the technology, right? So concurrent reads and writes at large scale. So this should be capable of doing it, this engine. Then in order to support these fast queries and fast aggregations, obviously there should be something like a columnar storage, some advanced indexing strategies that help you to really get access in real time to all your data, and also some automated indexing capabilities, right? Whatever you put into the database, as I said before, should be there for any kind of query that you execute against it. And last but not least, what I mentioned, whoever had to set up traditional relational technology in a high available and a horizontal scalable manner should be table stakes, but it's usually a lot of work, right? And that's also comes here out of the box. And now we not only talk about cloud or on-premise, we build this technology in a way that you can deploy it in the public cloud, either in the managed service, or you can self-deploy it. It can run on-premise inside of your data center, and it can also run on the edge with customers like ABB that also using our technologies in a marine solution where CrateDB is directly deployed on the ships. It gathers the data, it does some analytics on top of this data, some predictive forecasts directly on the ships, and as soon as the ship is back in the harbor, the data is automatically synced into the cloud, and then you can do this cross-fleet analytics and come up with new models and retrain your models that are then deployed into the edge. So, in summary, what does it mean? I mean, a native support of any kind of data, right, of multiple data models of any type. It must be available via standard SQL, right? A lot of specialized languages are not helpful here. The schema has to be dynamically adaptable, and obviously high performance, availability, and scalability are key for such a solution, right? We talk real-time AI, like in fraud detection of credit card transactions, like other customers do it, right? If you execute this transaction, you can't wait for a second or for 5 seconds, right? It has to happen in real time. So this single source of truth, a canonical business model that we can build up here, can now be kept in real time and can be kept up to date. Implications, again, people, time, and money, right? If we think about the people, it's just one skill set that we need, one technology that we need to learn and operate. In terms of time, it's much faster to go to market with these solutions. Changes, I mean, no data synchronization processes between different technologies, so very fast changes. And obviously on the money side, lower TCO because of less people that we need to spend their amount of time here on the actual development. And what we've also seen with a couple of customers is the lower footprint due to the storage engine, right? It's highly parallelized. Even on a single node, we can use the hardware in a much better way than other technologies. And then if we scale out on commodity hardware, that's a huge cost benefit as well. And less replication of data. You don't store it multiple times. Obviously, you'll need less resources to store your data. I already mentioned a few names. Let's go into some use cases that we see on this slide. It's a very broad range where you can use such a technology, obviously because of these multiple data models. Whether we talk these real-time dashboards and operations, here in the case of streaming videos, we talk about retail, where we modernize data stacks coming in from multiple databases, reducing it to one single technology. Or here in financial services, we also talk about risk management and fraud detection, right? Like the credit card transactions. And obviously, I mean, we have a lot of IoT colleagues here as well, like product and customer 360 when we monitor production lines, when we monitor manufacturing processes. And we also had a customer speaking earlier this morning from TGW. They built automated warehouse solutions, right? Whenever you order at the large European retailers, not mentioning particular names here, but it's most likely that the stuff, sports shoes or clothes or other retailing stuff, it's most likely that it's picked by one of their solutions, right? And so we are also the backend here to build a digital twin of these warehouse solutions. And many more. This is just a very, very small overview of a couple of logos. So this is today, right? That's the multimodal database of today. But what about tomorrow? where do we see the shift? Because what we want to talk about is business outcome. At the moment, we only talk technology, we talk database. But what I experience in a lot of conversations, hey, I need to increase my operational efficiency of my manufacturing. I want to increase my sales. I want to move into new countries, start new operations of my business, right? That's what we want to solve, actually. And this is the real problem we want to crunch. And in order to get there, we have a lot of tasks to do. We need to connect to the source data. We need to pre-process and integrate all this data. We need to model a canonical business model, obviously. Then we start to apply machine learning. We start to generate insights. And as a next step, we develop an application on top, a dashboard. And now all these AI-enriched applications or even generative AI applications come into play. That's still we talk technology, right? We need to talk business outcome. We need to shift our way of thinking into this direction. And if we look at all this stuff, we also have to take care of a lot of metadata management. We need to model and manage our AI models here. And we have to take care about security and governance. Yeah? If we talk about personal data, buying behavior, that's very sensitive data. So we should take care of it. And now this part comes in. How can AI help us here? And let me go back here in the traditional projects that we see and that I've also been involved in building data warehouse systems. You usually spend 80% of the time in just gathering the data, preparing the data, integrating it until you are ready for consumption. And then you still have a gap to your business users. And now imagine we could use AI capabilities to reduce these 80% to, let's say, 40%. Not that we get rid of the data engineer. No, all of a sudden they can spend much more time on the business outcome, on this gap that we need to fill, right? They can spend much more time understanding the data, applying better algorithms, building better applications, increasing the outcome. So, how can AI now actually help us? We can speed up the development and also the optimization of existing applications with the help of copilots. Think of the GitHub Copilot. I don't know if anyone knows GitHub Copilot here. Yes, I see a lot of hands up. Very good. So this is a good capability to generate code, right? And 40% of the code today can be generated. Now imagine your developers have 40% more time to crunch problems. This can also be applied to data problems. Second thing, enable context-driven analytics. I'll go into a little bit more details on the next slide, right? As soon as we understand all our data and we understand the semantics behind, with the help of large language models, then we are able to come up with much easier analytics. I just ask questions, right? And I get algorithms suggested. And last but not least, we get closer to something like data architecture ecosystems. The big problem in data and when working with data, there are no standards out there, right? And a lot of these projects just start from scratch. There's no standard definition of models. There's no standard definition of data integration processes. It's a super big zoo out there of technologies. And with these 3 bullet points, the key goal is to really democratize the access to data and more interesting to the actual insights that we can generate out of this data. And how can this look like? Let's have a look, a closer look how this could work. First of all, on the bottom of this slide, we see basically our integration process, right? We have the source data, we have our data integration processes, we have some transformation applied, and then we have business models and consumers, aka applications on top of that. And now with these huge developments that we have seen in the last month in artificial intelligence and natural language processing, we can start to derive semantic representations in the form of vectors of all these definitions, right? We have a lot of metadata of our source data. All of a sudden, we can ask, based on the metadata, we have to describe our transformations, our integration processes, and also our business model, right? This can now be understood and represented in such semantic context. And now the next level is then this contextual analytics layer. we can now use this context to perform additional analytics on top of that. Just give me some clustering, for example, of my data with a lot of questions that we need to answer. We can start with anomaly detection. We can even generate code, classification algorithms. And I show an example how this could look like later on. So with the key goal, if you look at the developer on top of that, we can now ask questions to our whole system. Which source data which source systems capture billing data? Which tables have anomalies when we talk about data quality processes? Which models predict future sales in our architecture? Which reports provides insight for our product planning? Right? All of these are now questions that we can ask to the overall system. We don't need to go into data catalogs. We don't need to read a lot of things. These are answers we can generate automatically. And before I go into this example, I would like to ask who of you is using ChatGPT or a similar technology and has used it? Okay, I see quite a few hands up there. Who is using it on a regular basis? And with regular, I mean really on a daily basis. I need to keep my hand up. So, okay, still quite a lot of hands up. Yeah, quite a lot of hands up there. Super impressive, right? Sometimes you don't have an idea how you want to crunch a problem. You ask a question there and get very, very helpful insights. Yeah. New libraries. I've recently some coding issues, needed to parse a lot of PDF files. ChatGPT recommended me a library I was not aware of. An hour later, problem solved, right? Wow, that was fast, instead of copy pasting from 100 PDF files. Okay, and now let's transfer this to development of data products. And here I brought a little example with me. Let me put me into the shoes of a data engineer in a large retail chain. And I get asked to come up with a system that predicts the sales in our stores. Maybe we resell food, right? It's, okay, now it gets autumn, maybe it's summer season, and we need to predict, do I need to order more meat or more sausages? Because a lot of people will do barbecues out there, right? So what I discussed with my business department is we want to have a web-based dashboard where my people can go in and see at these forecasts. And the planners really want to understand the future and the future demands before they actually do their orders. And if I give this now to a copilot, to a language model, it could come up with the suggestions because we were able to connect to a couple of source data. We know the metadata maybe. And it comes up with recommendations. Hey, you will need the following source data, right? You have a data source called store sales. Obviously, it contains your sales data for your product per store. And there's already a weather data service that you can help or that you can attach to and get external information from. Next step would be, okay, how do I integrate it into my existing model? And now my assistant could come up with suggestions and say, oh, you already have a store model and a product model in your canonical business model. This can be reused. You don't need to remodel it, obviously. You need to add sales and the weather data. I would suggest the following schema based on the source data. And you can easily then create these tables, put them into the database. And the next thing is really hard if you all need to do this manual, but let me generate some data integration processes for you, right? Extracting data and sending it somewhere should be a prompt, not days of work. So now we generate such ingest processes. Then the big question, which model do I need to apply? I mean, for forecasting, it's very straightforward. A lot of people think about ARIMA models. But here the chatbot can come up, use a seasonal ARIMA model. We talk about weather, right? It's a lot of seasonality. It's sales data, so most likely there's seasonality in there. Can suggest me 5 different steps that I need to do. And ideally, we can also generate the code in the background. Could ask it to come up with some Python code. We had some interesting discussions earlier at the booth, right? Does it really work? Obviously, there needs to be some fine-tuning to be done. We need to limit the solution space a little bit for the general models. And then they are also able to come up with good good suggestions for us and good first versions. And this is also very important to have the pause button here, right? The data engineer and the data scientist, they will still have work because they still need to review what is generated here, right? And you might need to fine tune it here and there. And then last step, let me render the output in a dashboard. Well, all of this can be generated nowadays. You have this initial plot, you can come up with a whole fully fledged web application. And all of a sudden, I am able now, as a data engineer, data scientist, go back to my head of procurement and can tell him, hey, this is what I built. Let's iterate on it. Let's see if this already helps us. And what are now the parameters that we need to tune? What are the bits and pieces that we need to change? And usually, let's assume this model works. And what usually comes in now, we need to put it into production, which is obviously also a big step. When traveling here, my train broke down, unfortunately, and I shared the taxi by chance with a head of production from a automotive supplier. And we talked exactly about this stuff. And he told me, yes, our central IT comes up with new technology every half year. And then the engineers come up with some new technology. I don't get my problem solved. They continuously change the infrastructure stack, the software stack, but they don't solve my problem. Right? And I can't get it to production. I simply want to operate my operational efficiency. And this is now that we are moving into as a technology. First and foremost, in the center of it, you see this multimodal database, right? And without it, it would not be possible to come up with such a platform. And I'm going to elaborate on it, because then you have this spaghetti architecture, right, that we have seen before. And now, there are capabilities to really identify and connect to your source data, right? You should be able to read all this metadata to also teach and fine-tune your co-pilot on this data. Obviously, we need to pre-process our data. We need to profile it, we need to cleanse it, deduplicate it, etc. And then have either virtual or federated access, or we need to generate physical data pipelines, right? If we really need to replicate data. Then here at this stage, we have a canonical business model. Can be served via standard SQL, and or is the basis then for machine learning to generate insights via algorithms that you write in Python or R or Scala, whatever you want to use on top of that. There are application services that you can drag and drop together your actual application, and obviously there has to be a way to integrate any kind of third-party service. Whether it's a visualization tool like Tableau, like Qlik, Power BI, can be orchestration tools, Airflow, Prefect, or when we talk about application services, something like Dapper, right? And this is the prototype part that I've showed you before with the help of this platform Copilot. And now when we need to put it into production, such a platform has to offer much more, right? We need processes to allow for good data governance. Data cataloging has to be there. We need proper security and compliance. We need integration into data ops, DevSecOps, ML ops, right? We talk about very complex software projects here. And this should come out of the box to support you and to really speed up your development here. And when we talk about a deployment model, I mean, we are here in Europe with a lot of data protection laws and also a very protective mindset of data. Not everything can go to the public cloud, right? There will still be a lot of work to be done on premise, on the edge even. Maybe you have a brittle connection to the internet, so it's not possible to have an always-on connection, so needed on the edge. Or when we talk about production monitoring, by intention, you don't want to have it connected to the internet, right? So this platform can be deployed to where you really need it. Yeah. And let's compare it. What I said before, right? Why is it possible around such a technology? Of course, you can do spaghetti, right? But you will spend a lot of time in this architecture, spend a lot of time on integrating these different technologies. And that's the key question, right? Where's the time to talk about the business outcome? You want this out of the box. It should just work for you. And who thinks that is also a bit far taken, we can have a demo at our booth as well. where we have an example here of this natural language interface. We just put some query there. It's sales data, where I put in my question with my 2 favorite products, right? Where have it been sold? And I want this month-over-month comparison, for example. Yeah. Not a super complex query, but to start and to write it will take some time if you're not doing this on a day-to-day basis. So this agent comes up with this query and also realizes sometimes they generate wrong queries that are not executable, right? And that's the beauty that I also learned about these large language models. Just send the error message. And it comes up with a proper query afterwards. Very impressive, right? For more complex things, it's a simple example that it fits on this slide here. And for more complex things, you need to do 2-3 iterations, and it really ends up with a query that's executable and really delivers the results that you want. Of course, a little output of the data that we want to visualize. And then it's not far away to also generate the plots. In this case, a simple bar chart on top of that. You can start to visualize your data and can start to work with your data. Okay, and I hope that sparked some interest in this topic. With the recent advancements we've seen, right? Not just the multimodal database, but also in artificial intelligence, the large language models, about vectorizing your data. And again, this can be done in one single technology here. And I'm happy to invite you to our booth, 254. It's just, if you go out here, you will basically pass by this booth. We also have a couple of live demos on our booth today at 3:45, where we show the integration to MLflow, also very famous Python framework. So you can put CreateDB as a backend there as well. And also some time series modeling that we want to show you how to apply AI on top of that tomorrow at 10 a.m. And of course, at any time when you pass by. And again, something I want to mention as well, we also have a customer who spoke earlier today, TGW, as I mentioned before, about not all time series are equal, about the digital twin of warehouse solutions. He's also around, happy to talk to you. I think it's always good to hear it also from a different perspective, from people actually really using this technology here. So having said that, thank you very much. If there are some questions, we are here for the next 2 days. Happy to discuss this topic with you. Thank you.